This tutorial walks through the process of converting a quadratic function from standard form, the one on the left, y equals ax squared plus bx plus c, to vertex form, the one on the right, y equals a bracket x minus p all squared plus q. To do this, we use a process called completing the square. The steps are listed here. We'll go through them very quickly and then get into an example to see how they're used. So the first step of completing the square is to factor the a value out of the first two terms. We're going to leave it with the c term as it is. We're just going to focus on the first two terms. Once we've factored the a value out, we're going to use the coefficient of the x term. We're going to take half of that number squared and we're going to add it and subtract it. Now the reason that we're doing that is that we want to force it to be a perfect square. Now we can't just add the number that's going to work because then we change the value of the expression. So we need to make sure that we add it and subtract it. So half of that coefficient of the x term squared, we add it and we subtract it. Once we've done this, the first three terms inside the brackets form a perfect square. We're going to factor them as a perfect square. Next up is distribute the a value, the one that we factored out originally, across the brackets or through the brackets, and then collect your like terms. Once you've done that, you're in vertex form. Let's look at an example. So here's an example, y equals 3x squared minus 18x plus 5. We're going to complete the square in order to find the vertex. So the first step is to factor the a value out of the first two terms. When you do that, we should get 3 bracket x squared minus 6x, close the bracket, and the plus 5 remains unchanged. So here it is again, but we want to force the first three terms inside this bracket to be a perfect square. To do that, we need to take half of the negative 6, which is negative 3, square it, negative 3 squared is 9, and we're going to add that value and subtract it so that we don't change the value of the expression. Now the first three terms inside the brackets here are a perfect square. We factor them as a perfect square. A little trick to factoring them as a perfect square is that your perfect square is going to have an x in it, and it will also have half of the coefficient of the x value. So just to take a little shortcut, if you don't like the shortcut, then factor this as a simple trinomial. So half of negative 6 is negative 3. That's what's going to go in the brackets. So again, those first three terms are built into this squared, this binomial that's squared. We still have a minus 9, and the plus 5 doesn't change at all. The next step is to distribute the 3 through the brackets. So we multiply 3 by the two terms inside the brackets. Just a quick note here, we cannot distribute the 3 into the brackets here on the last line because x minus 3 is squared. Remember that exponents come before multiplication, so we just leave the 3 as a factor in front of the x minus 3 all squared. And then we distribute the 3 to the negative 9. Negative 9 times 3 works out to negative 27. Add negative 27 and 5 and we get negative 22. We've just changed from standard form to vertex form, and we can now read off the vertex. So the vertex in this case would be 3, negative 22. And let's look at one final example. So this example had a coefficient in front of the squared term. Let's look at an example where there is no coefficient in front of the squared term. So here's another one. Find the vertex of the function y equals x squared minus 6x plus 7. So if we tried to factor the a value out of here, we'd be factoring out a 1. Well, that doesn't change anything, so we don't need to do that step. We can just skip it entirely. So we skip that step. The next step is to look at the b value, in this case the coefficient of the x term, and we're going to take half of it. So half of negative 6 is negative 3. We're going to square that. Negative 3 squared is 9. And we're going to add and subtract 9. And we do that to force a perfect square amongst the first three terms here. So these first three terms, the x squared minus 6x and plus 9, form a perfect square. We can factor it. Those first three terms will factor to x minus 3 all squared. We still have a minus 9 and a plus 7. Collect our like terms. And we get y equals x minus 3 all squared minus 2. It's in vertex form. It's very easy now to read off the vertex, which is at 3, negative 2. That's the process of converting from standard form to vertex form to allow you to read off the vertex, determine the maximum and minimum of a quadratic function.